We're back on video again. It's been a while. Now this is obviously due to the way things have changed in the school environment. So this is the first one of these that my current Year 12 will have had made for them. So welcome, and yes, you can see there's lots of videos. This is related to the work that was set for you today being November the 20th. Making a solution. Couple of words. There's my cat making a racket in the background. One of two cats. Who knows what it'll do. It's a bit of a law unto itself. Solvent. I'm sure with your immense intelligence you know these things, what they are. I've written solid. It doesn't have to be a solid. You could dissolve other things. You could dissolve liquids or gases into a solvent and make a solution. Dissolving, that's a process of getting a solid into a liquid, going into a liquid, dissolving into a liquid. And we have a volumetric flask. That's the piece of equipment that I'm sure you've got a recall of. I'm not bound but best at drawing things, and it's that thing with a calibration line on it. Usually six formers. 250 centimetre, cat is making a racket. 250 centimetre cubed is the big one you normally see. Sometimes you get to have a 100 one. Technicians have much bigger ones. They have like up to 5 litre ones, certainly at the schools that I work at. And yeah, it comes with a little stopper in. And you, certainly if you're my sixth formers, you've already been using these. So that's the equipment thing. There's a few questions about that on the sheet. What we're looking at is making a solution, and more importantly, what concentration will it be? And there's two ways, but they're both the same. There's two ways to do it. It very much depends on how you feel about it, or maybe what you were taught, maybe when you were in year 10, maybe year 11. This is my preferred method because this is the way I've always done. This is the way I was taught when I was, smaller. So it's the volume in centimetre cubed divided by 1000 multiplied by the concentration. Now in chemistry, concentration got to be moles per cubic decimetre for A level. Oh, there goes the cat again. And at GCSE it's sometimes grams per cubic decimetre, and the old fashioned way of writing it with a slash and all that. Nah. A level, moles, decimetres to the -3. So that's my preferred method. What this method does is it takes that bit out and does it first, and that converts the volume into decimetre cubed, which is all that is doing. And then you do volume times concentration. So here you have the volume converted into decimetre cubed times concentration. This is exactly the same as that. Now, the questions that are attached to this video, or are attached to the homework that was set for you, if you're my students, is firstly the questions are working out the concentration. So it's concentration. So you want to leave the concentration there, so it's moles times 1. My cat's making a racket. It's that. Or if you're doing this version and you've already converted it, concentration moles over volume dm3, which will be in dm3. I'm going to do a couple of examples just to make sure you don't get lost on it if you've looked at it and gone, oh, don't really want to do it yet. So I'm going to take a little break. I have to take these little breaks to clean the board up and get ready to go. See you in a minute. So here's example 1. It's very similar to the ones on the sheet if you've printed the sheet out already, except this one's not on the sheet. And this question is, what is the concentration of the HBr solution? There are 16.18 grams dissolved in 4,000 cubic centimetres. That is supposed to be exactly 4,000. I don't want to get into significant figures where this is treated as one significant figure. And it's 4,000. It's water as well. So you need to always calculate the formula mass of the substance. 79.9 for bromine 1, 80.9. You need to work out how many moles you're using, which is 16.18 divided by the formula mass. It comes out as 0.200. Quite a good sign when you're doing off many exam questions is that when you get a nice sensible number, it probably means you're on the right track, although it doesn't always guarantee that. And then you plumb that into that equation. This is the one that I prefer because it's the one I've always used. So we have 0.2, the cat is back. Here's the cat that's making all the noise. There we are. So, put it into the equation. There's the number of moles. Concentration is the question. 4,000 is what we're using, divided by 1,000. Need the concentration, rearrange it, 1,000 up on the top on the other side, 4,000 down over there. There it is, concentration on its own, and you put those into a calculator. Or not as a calculator if you're quite good at mental maths, and it's 0.0500 moles per cubic decimetre. That's the answer. We'll do another example similar to this, a little bit more complex a substance, and then another example where we dilute an already made up solution, and then we're done. See you in a moment. So here are example 2, slightly more complex a substance, so 4.65 grams. This is sodium sulfate decahydrate. What that means in terms of working out the formula mass is why I put it up here as an example, and it's 225 centimetre cubed of water. So firstly you need to work out the formula mass. Now I have this thing about certain things are worth remembering. So sodium is, 2 lots of sodium is 46, which you can look up. Sulfate ions are 96.1, 32.1 for the sulphur, 4 lots of 16 for the oxygen, which is 64. Add that together, you get 96.1. I encourage people to go sulfate 96.1, carbonate 60, hydroxide 17. There's a few that I encourage you to do. And the other one is water. Water is 18. This means that in the structure here there are 10 lots of water holding the structure together is how you get the crystals to form. And 10 lots of 18 is 180, hence the 46, 96.1, 180, the answer is 322.1 as a formula mass. How many moles? There, this time, not a straightforward number, because I just randomly picked a 4.65 grams out of my head when I was setting this up. So that is the number of moles. The concentration, I've shortened the calculation now to the number of moles times 1,000 divided by the volume, 0.0642. And there's the answer. Really that was about having a more complex substance with some water crystallisation in. And we're going to do one more example where it's a different thing in diluting an already made up solution. And then I'll leave you to do the rest of the questions on the sheet if you haven't done. See you in just a moment when the board's ready. So example 3, just a dilution of an already made up solution. I'm going to use 20 cubic centimetres of 0.525 moles per cubic decimetre. It says it's a solution of HCl. The actual mathematics makes no difference what substance is actually in the solution because the MR doesn't come into it. And you're diluting it up to a volume, in this case I've chosen 750. Right, so the new concentration is what we're trying to calculate. Now there's a long way and a short way to do this. The long way is to work out how many moles you've got in 20, which is there, it's 0.105, and then you go, I'm taking my 0.105 moles, that's going to add it extra water to get it to 750, so it will be 0.105 times 1,000 over 750, and the answer is 0.140. And if that makes sense to you, best do the way that makes sense. The short way is to, this is the scaling down of the concentration. So it went from 20 cubic centimetres to 750 cubic centimetres. So you scaled the concentration down by adding all the water, 20 divided by 750 or 2 over 75. So it's 0.525 times 20 divided by 750, and the answer obviously, because it needs to, it comes out the same. Now, also with the video, if you're not one of my students and you're looking at this, if you are, subscribe. If you're one of my students in Year 12 and you haven't subscribed, subscribe. And there are some attached questions if you haven't been sent them already. And the answers will be a little bit later because I've yet to type them up attached to this video so you can get them when you're ready. And that's it. I suspect over the next fortnight there will be more videos. Well, I know there will because that's what I'm going to do. And I'll see you in those. I look forward to it. Bye bye.